Let's talk about mental training and visualization. Now, perhaps surprisingly, mental training and visualization has been studied since the late 1800s. There's actually a paper published in 1880 by Galton called The Statistics of Mental Imagery. So long ago, people were quantifying and trying to understand how is it that people come up with mental images and how they can apply that to learning things more quickly and more stably over time. Now, as I mentioned earlier, mental training and visualization relies on a process that we call neuroplasticity. Neuroplasticity is a term that many people have heard, and it encompasses many different things. So broadly speaking, neuroplasticity includes developmental plasticity, which is the sort of plasticity that occurs between about birth and age 25. And that can be summarized very easily as passive plasticity. In other words, the sorts of changes that happen in one's nervous system simply by engaging in the world and experiencing life as a child, as a young adult, as an adolescent, and as a 22, 23, 24-year-old, etc. Now, of course, it is not the case that on your 25th birthday, you close out passive developmental plasticity and start engaging in the other type of neuroplasticity, which is adult neuroplasticity. It's a gradual tapering off of developmental plasticity that occurs between age 0 and 25. And for some people, it might occur somewhere around 26, for other people around 23. When we say 25, we're really just talking about the average age in which passive plasticity tapers off. However, starting fairly early in adolescence and extending all the way out into one's 80s or 90s or 100s, should one live that long, is the other form of neuroplasticity, which is adult neuroplasticity. Adult neuroplasticity is very different than developmental plasticity because it is the sort of plasticity that one can direct towards one's own specific desired learning. So if we wanted to get a little bit technical here for sake of clarity, not for sake of confusion, we would say adult plasticity is really about self-directed adaptive plasticity. And the reason we call it that as opposed to something else, or simply adult plasticity, is that there are many different forms of neuroplasticity. There is, for instance, maladaptive neuroplasticity that occurs if one gets a really hard head hit and concussion. There will be changes to the brain and nervous system, but those changes to the brain and nervous system do not allow it to perform better. In fact, it often impairs the brain and nervous system's ability to function and therefore is maladaptive. So I don't want to get overly wordy with a number of different terms here, but I do think it's important to understand that we have developmental plasticity, again, in which the brain and nervous system changes simply in response to experiencing specific things, for better or worse. And there's adult self-directed adaptive plasticity, in which one can direct specific changes in terms of learning things cognitively or learning things in terms of motor function, so sport, dance, etc., or a combination of the two. Now, just to really clarify what I mean by developmental versus self-directed adaptive plasticity, I mentioned that self-directed adaptive plasticity actually can start in adolescence, right? Even though there's ongoing developmental plasticity. I mean, let's be really direct. The brain of a 14-year-old is very different than the brain of that same individual when that person is 21, because there's ongoing developmental plasticity. However, starting at about adolescence, we can all start to decide what it is that we want to learn and engage in self-directed adaptive plasticity. Now, the way to engage self-directed adaptive plasticity, regardless of whether or not you're a 13-year-old, 14-year-old, or you're a 90-year-old, or anywhere in between, is that it requires two things. The first thing it requires is focused, dedicated attention to the thing that you're trying to learn. That's the first step. And that actually triggers a number of different chemical and electrical processes in the brain that are often associated with agitation and frustration. And believe it or not, the agitation and frustration is a reflection of the release of specific chemicals, in particular norepinephrine and epinephrine, also called noradrenaline and adrenaline in the brain and body, that creates this discomfort and this heightened level of alertness and attention that many of us don't like and tend to back away from. But it is exactly that chemical, or I should say neurochemical milieu, which signals to the neurons, the nerve cells in the brain and elsewhere in the body, that something needs to change. Because if you think about it, if you can do something perfectly, or if you try and do something and it doesn't cause any neurochemical change in your brain and body, well, then there's no reason for your brain and its connections with the body to change in any particular way. Okay, so you need focused, dedicated attention to the thing that you're trying to learn. It's often accompanied by agitation, frustration, etc. So that's perfectly normal. In fact, that's a signal that things are going right, meaning they're headed towards learning. But there's a second component that's really required for self-directed adaptive plasticity, and that's periods of deep rest, in particular, a good night's sleep, in particular, on the night that follows that focused attention to the thing you're trying to learn. There are now hundreds of studies in both animal models and in humans showing that it is really during sleep and other states of deep relaxation, things like meditation and non-sleep deep rest, which I've talked about before on this podcast, but really during our main night of sleep, that the rewiring of neural connections, that is, the actual neuroplasticity, takes place. So the verb neuroplasticity, the rearrangement of connections between neurons, really occurs during sleep, in particular on the first night following an attempt to learn something through this focused attention. Now, developmental plasticity, which is passive, also requires good sleep. It's slightly different, or frankly, it's a lot different in terms of the underlying mechanisms than self-directed adaptive plasticity. But because today we're mainly talking about how to learn faster through mental training and visualization, and that really maps more closely onto self-directed adaptive plasticity, I just really want to emphasize this two-step process. There has to be focused, dedicated attention, and then there needs to be sleep, and in particular, sleep on the first night following that training. Now, should you have the unfortunate experience of getting woken up in the middle of the night following trying to learn something, or should you simply not be able to sleep for whatever reason on the night following a bout of learning or an attempt to learn, do not despair, because it turns out that there are what are called second and third night effects also. Once you sleep, you will learn. Those neuroplastic events, the reordering of connections that we call synapses, and the changes that occur in neural circuits that reflects what we call self-directed adaptive plasticity, that still will occur. But ideally, you got a great night's sleep on the first night following trying to learn, and the second night, and the third, and so on and so on.